right, let's compare two mobile options. We have BoostMobile, who's offering a 64 gig iPhone 6 Plus for $749.99, unlimited talk, text with a gig of high-speed data for $35 per month with no contract. AT&T offers the same phone for $399.99, same plan for $50 per month, but it requires a 2-year contract. So we want to know how many months it will take before the two options cost the same amount. So we don't know how many months it's going to take. So let's set this up as an equation. The first option is $749.99 plus $35 times however many months you're using this plan. We want that to be equal to the AT&T's option of $399.99 plus $50 times however many months. So we have a multi-step equation here. The goal is to bring the variables to one side of the equation and the constants to the other side of the equation. And I prefer not to work with negative numbers, so I'm going to bring my 35m to the right-hand side of the equation by subtracting it from both sides. If you feel confident enough to subtract the $399.99 to bring it to the other side of the equation in the same step, that's perfectly fine. But if you prefer to see them in two separate steps, that's good as well. So we have 15m here, and these are gone, and we are left with $749.99 equals $399.99 plus that 15m. So we want to isolate the variable. We're going to take the $399.99 away from both sides. So we'll subtract from both sides. And so we have almost 750 minus almost 400. So our answer is 350 here. No need for a calculator. And 15m. So one more step to our equation. We want to get the m by itself, and it's being multiplied by 15. We divide both sides by 15. And m is going to be equal to, again, no need for a calculator here because I see that there's a 5 in common. 35 divided by 5 is 7, so 350 divided by 5 is 70. And 15 divided by 5 is 3. But that doesn't seem like a reasonable number to most people. They would prefer to see it as a decimal or a mixed number instead of an improper fraction. So 70 divided by 3, 3 goes into 7 2 times. And we'll take 3 times 2 and get 6. So we have 1 left over. 3 goes into 10 3 times. And we'll have 1 left over. So 23 1/3 months is how long it takes before those two plans are equal. Not a big surprise, because AT&T requires a 2-year contract. So at least in this comparison, there's no benefit to buying an off-contract phone with a cheaper plan versus buying the subsidized phone with a more expensive plan. All right, let's go back and check our work. So we determined that the solution to this equation was 23 1/3 months, or 70 thirds. So that means that $749.99 plus 35 times our 70/3, or 23 1/3, or 23.3 repeating, all are the same, should be equal to $399.99 plus 50 times that 23 1/3. So let's bring up a calculator and make sure that this is making sense. When we take 70/3, we get our 23.33333 repeating. Let's store that. We can just store it in memory. Order of operations says to take multiplication first, so times 35, and then add the $749.99. And we get a total of $1,566.67. So let's see if that's equal to 50 times our 23 1/3, which is our thing that's stored in memory, plus the $399.99, and we get $1,566.66. So it checks out. So what this means is the total cost of an iPhone 6 Plus on both plans over roughly 2 years is over $1,500. So here's a second example. The process for multi-step equations is always to bring the variables to one side and the constants to the other. So I can subtract 3x from both sides. And if you're comfortable with this, you can also say, since I'm bringing the x's to this side, I need to bring the constants to the other side. So a positive 16 or an adding 16 on the left side means I'm going to take away 16 from both sides. It becomes negative on the right side. So 5x minus 3x is a total of 2x. 16 minus 16 is gone. 3x minus 3x is gone. And a negative 11 and a negative 16, they're both negative, so we add them up and give them the negative sign, negative 27. Now we have 2 taken times x. We need to simplify dividing by 2. If we divide the left side by 2, we have to be fair to the right side and divide it by 2 as well. And you have several options here. You can leave it as negative 27 halves, unless someone tells you that you need to give it as a decimal or a mixed number. So we can make it a mixed number and say that that is negative 13 and a half. Or we can call it negative 13.5. So let's go back and check. 5 times negative 13.5 plus 16 should be equal to 3 times that negative 13.5 minus 11. Order of operations says to multiply first. So 5 times 13.5 with a negative sign in front, plus 16, so negative 67.5 plus 16 will get us a negative 51.5. Is that equal to 3 times a negative 13.5? Or negative 40.5 minus 11. Both are negative, add them up, give them the negative sign, negative 51.5. It checks. Okay, let's solve this example two different ways. One way involves finding common denominators and bringing the variables to one side, the numbers to the other. So let's start with that way. First of all, we know that we need to get all the variables to one side and the constants to the other side. So if we're going to take our x over 5 to this side, that means we'll take our constants to the other side. So we'll take away x over 5. From the left-hand side, we also have to subtract x over 5 from the right-hand side. So this is a positive 1x. So how many fifths is it? Well, 1 is the same as 5 fifths, so this is 5x over 5 minus 1x over 5. We're going to get a total of 4x over 5. Now, we also need to take that 1/3 away from this side. So we can subtract 1/3 from both sides. And we will get, well, 3/5 minus 1/3 need common denominators. The common denominator of the least common multiple is 15. So if I take 3/5 times 3/3, I get a common denominator of 15. So we will have negative 9/15. And if I take 1/3 times 5/5 to get my common denominator, I will have a negative 5/15. So negative 9/15 and a negative 5/15 is a total of a negative 14/15. Now, 4/5 x or 4x over 5 are the same thing. So we can bring that x off to the side and call that being multiplied by 4/5. The opposite of multiplying by 4/5 is dividing by 4/5 or multiplying by the reciprocal, 5/4. When I do that, the 5's cancel, the 4's cancel, and I'll have a plain old x. But if I'm multiplying the left side by 5/4, I also have to multiply the right side by 5/4. The 15 and the 5 cancel, left with a 3 in the denominator. The 14 and the 4 cancel, I'll be left with a 2 in the denominator and a 7 in the numerator. So 7 times 1, 3 times 2, and don't forget your negative sign. So x becomes negative 7/6. Let's work it a different way. Back to the original equation, x plus 1/3 equals x over 5 minus 3 over 5 another way of thinking of this is you can multiply everybody by the least common multiple, and that will help clear your fractions. So the least common multiple of a third, x over 5, and 3 over 5 is 15. So if I multiply the left side by 15, I also have to multiply the right side by 15. So distributive property says to take 15 times x, and also to take 15 times a positive 1/3. 15 thirds reduces to 5. 15 times x over 5, again distributive property here, is going to become a 3x, because 15x over 5 reduces to 3x, and then 15 times a negative 3/5. 15 divided by 5 is 3. 3 times 3 is 9. So we can now simplify by bringing the x's to one side and the constants to the other side, subtracting 3x from both sides. We get 12x. We have a 5 added on to it. If we want to bring that to the other side, we're subtracting both sides by 5. And we get a negative 14. Dividing both sides by the 12, that's multiplied by the x to isolate the x, get it by itself. And x becomes negative 7/6. So don't be afraid of fractions. They're your friends. You can simplify by multiplying by the least common multiple, or you can get common denominators and actually add and subtract those fractions as necessary. To check this, we've worked it two ways, so it does check out, but you can substitute the negative 7/6 everywhere you see x. Negative 7/6 plus 1/3. Is that going to be equal to negative 7/6 over 5 over 1, understood 1 under there, minus 3/5. Let's get a common denominator on the left-hand side. That will be 6, so I have to multiply the 3 by 2 to get a 6, multiply the numerator by 2 as well. So negative 7/6 plus 2/6 is a negative 5/6. And is that going to be equal to, well, how do I get rid of the dividing by 5 over 1? I can multiply by 1/5. As long as I'm multiplying by the same thing over itself, I have not changed the value of that fraction, just its appearance. So we'll get denominators going away, negative 7/30 minus, let's make this a common denominator. In order to get 30ths, I'm going to have to take the 5 times the 6. But if I multiply the denominator by 6, I've got to multiply the numerator by 6. So a negative 7/30 and a negative 18/30 becomes a negative 25/30. They have a 5 in common, so it will reduce to negative 5/6. It checks.